videos, we've been talking about the linear equations and how to show them on the coordinate plane. In this lesson, I will introduce you a set of linear equations called the simultaneous equation. First of all, I try to explain the background behind the simultaneous equation so that you can understand what they are. Then I will tell you three methods to solve these equations. Then finally, we will be dealing with the word problems that are linking to the simultaneous equation. So to start, what are simultaneous equations? Simultaneous equations have two unknown values, that means the variables, and we need to find the values for the two unknown, which make both equations true. So let's have a look at this. So focus on it has got two variables and also it has got two equations that we need to find the solution for the both equations. We've got x at the same time y, so two unknowns with two equations. Now we've got a linear equation x minus y equal to. Let's find the solutions for this equation. Let's start with x. When x is 10, yes, y is 8. When x is 9, y can be 7. And then it goes forever, right? So x can be any number, then y is just 2 less than the x. So for the solutions for the x minus y equal to is infinite. Now let's have a look at another equation that is 2x plus y equal 4. Let me say when x is 1, y is, so 2 plus y equal 4, so y is 2. Then let's see, when x is 2, then your y is 0. Then x is 3, I try to find the y. Y is 6 minus 2 is 4, so minus 2. This equation also has got a lots of solutions, right? So this one is when x is any number, y is, so let's see, y is a minus 2x plus y. So you can see the pattern, right? So y can be minus 2x plus 4. So these two equations, they all have a lots of x and y's. Then how can we find the solutions for the both equation? That's our question. In previous lessons, we've been talking about the graph, right? The graph is really helpful because we can see how the equation works. So let's use a graph. First of all, let's draw the x minus y equal to graph. Linear equation, always standard form is y equal mx plus c. Let's change this into y equal x minus 2. Then since you know the y-intercept and then gradient, we can draw the graph, right? You all remember this? So now let's draw our graph. So first of all, y-intercept is minus 2. Let's begin with minus 2. Then gradient 1, 1 right, 1 up. So connecting 2 points, that can be our graph. Then now let's have a look at the second equation. So make it into the standard form, that is y equal minus 2x plus 4. Then so identify our y-intercept and then gradient. Then let's draw this graph as well, that we will see the solutions. So starting by the y-intercept 4, then so 1 right and 2 down. That's our gradient. Then let's connect these 2 points together. And now we've been talking about that. We're looking for the solution for satisfied with the both equation. That when we see the graph, we clearly see that there is a solution that are true for the both equation. Can you see that point for the intersection of the graph? So let's see the coordinate of the point. Let's say there is a point of the intersection. This point is a 2, 0. That means your x is 2, then y is a 0. Look at the graph. So this point is on the y equal x minus graph, right? That means it's solution for the x minus y equal 2. Then this point is also on the 2x plus y equal 4 graph. That means this is a solution for these two graphs. So make both equations true. We found the solution. So this is how you solve the simultaneous equation. Now, there are three ways solving the simultaneous equations. First of all, drawing graph, then substitution, then eliminations. In this video, we're going to talk about the drawing graph and then substitution method. Now, have a look at these simultaneous equations. We've got y equal x plus 2 and we have y equal 5 minus 2x. Let's identify our gradient and y-intercept to draw the graph. So, begins with the 2, the gradient is 1 right, 1 up. Let's join the dots together. That makes our graph y equal 2x. Then let's move on to the y equal 5 minus 2x. Let's change this into the standard form. That is y equal minus 2x plus 5. Then we can see our y-intercept and then gradient. So y-intercept is a 5. The gradient is, let me move 1 left and 2 up. Then here is another point. Then let's connect these two lines. Then we can come up with the y equal minus 2x plus y. Then can you see the point of intersection? So the coordinate of the point of intersection is x is 1, right? So 1, 3. That means when x is 1, y is 3. So this solution is answer for the y equal x plus 2 equation, and then also solution for y equal 5 minus 2x. And next graphs. So we can quickly draw our y equal x graph. We already know when x is 1, y is 1, x is 2, y is 2. So let's see the graph. It path 0.0. Then our second equation, let's make it into the standard form. Y equal 4x plus 6. So now y-intercept is 6. Then let's check our gradient. 4 is when move to the 1 right, move 4 up. Then we can have the line graph. Good. So now can you see the solution for the simultaneous equations? Yes. Let's write down the coordinate of the point of the intersection. Then that is, let's see, minus 2 and minus 2. That means when x is minus 2, your y is minus 2. So these are the solutions for the both equations. So far we understood how the simultaneous equation work by using graph, right? Now it's time to talk about the second method that is called the substitution. So what is the substitution method? So here we have a pair of simultaneous equations, x plus y equal 10, x minus equals 6. So step for the substitution method is first we need to rearrange the first equation to give the value of y in terms of x. The reason we rearrange this is we want to make the equation into y equal something. So let's see, let's rearrange it. Y equal, then we can see we move the x, so y equal minus 6 plus 10. So once we rearrange the equation in terms of y, then what we need to do is simply substitute for y in the second equation. So can you see the y here, right? Then instead of y, we just put minus x plus 10 because they are equal, right? Substitute this in the y. Then we can come up with the new equation. Let's write x minus 1. Then let's have a bracket. So minus x plus 10, that is y, right? So bracket is important. then equals 6. Then let's expand our bracket. Now we've got your equation. Have a look at it. It has got only one variable. Since we've got two variables, so that we couldn't find the answer, but we have a two variable, so one variable is aim for the substitution. So let's expand our bracket. So x plus x minus 10, that gives us 6. Then we've got 2x equals plus 10, it gives you 16. So your x is 8. Since we found our x, then we can find the y easily, right? Just put 8 inside the x. You can choose one of the equation. Let me use the top one. So instead of 8x, I put 8. Then 8 plus y is 10. So that we can see y equals 2. This is the substitution method. Just remember, simultaneous equation has got two variables, so we couldn't find the values for the x and y. That's why we try to remove the one variable, so that at the end we've got u equation with only one value. Now here we have a simultaneous equations, two equations with two variables. So your unknowns is A and C, right? So now let's rearrange the first equation as a C equal something, C equal expression. So minus C equals 3 minus 3a. Then C is minus 3 plus 3a. So this is the expressions. So now let's substitute this expression into the C. So have a bracket. So minus 3 plus 3a, then minus a equals 5. So we've got a new equation with only a. So now minus 3 plus 3a minus a, that is a 2a. So let's simplify them. Then 2a equals 8. So our a is 4. Since a is 4, then let's go back to our equation. Then I'm going to put 4 inside the first equation. So instead of a, I'm going to put 4. 3 times 4 minus c equals 3. Then 12 minus c equals 3. So let's see. C it can be 9. Right? So we've got a pair of solution. So a equals 4 and c equals 9. And this solution is answer for the first equation, and also this is true for the second equation. Now we've been looking for the drawing graph and then substitution method. Now let's have a look at this question. Find the coordinates of the intersection of the straight line. Then we've got two equations that it looks a bit complicating. So I'm going to try to solve this question using both methods so that we can see both methods work together. First of all, instead of drawing the graph, I try to find the solutions for the both equation using the substitution method. I found that 2x minus 2y equals 4. Then we've got a 2x in the both of equation. So 2x equals 4 plus 2y. So I'm going to stop here because we just, substitute 4 plus 2y into the 2x. Then it's simpler, right? Then instead of 2x, let's put 4 plus 2y. Then remember to have a bracket, say plus 4 plus 2y equals 12. So now we come up with our new equation with only one variable. 6y minus 4 minus 2y equals 12. So you've got a 4y that gives you 16. So y equals 4. Then your x is, let's put the 4 inside one of the equations. So let's calculate y. So 2x minus 8 gives you 4. Then 2x is 12. So we can find our x. X is 6. So now we come up with our solution for the simultaneous equation. That is 6, 4. Now that definitely coordinate of the intersection, right? But let's double check with graphs. So let's draw the graph very quickly. The first one, let's change this into the standard form. Minus 2y equal minus 2x plus 4. So y equals x minus 2. Then our y-intercept is a minus 2. Then your gradient is 1. So let's connect the 2 points. Then this is a graph for the y equal x minus 2. Second equation is, so 6y equals 2x plus 4. Y equals 1/3 x plus 2. And then let's begin with our y-intercept. 1/3 is our gradient, that means 3 right and 1 up. Then let's join them together. Then now let's find the point of intersection. That we already know that 6.4 is the solution for these two equations. So let's double check with this. So 6,4, this is the point of the intersection of two equation. Right, well done. We've been talking about the simultaneous equations and then solve the equations using the graph and substitution method. Then next video we are going to talk about the last method that is called the elimination. So I will see you next lesson. Bye.